teacher and curriculum specialist Brad Fulton has over 3 decades of classroom experience helping students find success in math, science, and STEM. His innovative and engaging activities make teaching simpler for teachers and more accessible for students. As California's Middle School Educator of the Year, Brad is in high demand at conferences, workshops, and district trainings throughout the United States. He has authored over a dozen educational books and video trainings that demonstrate his classroom-proven and student-approved techniques. Join Brad now as he shows us how to make learning come alive for our students.
Hi, my name is Brad Fulton, and I'd like to welcome you to the Teacher to Teacher Press video series, Algebraic Thinking. As we begin to think about algebra, we need to take a look at it with fresh eyes. When I was a student, algebra was just a lot of numbers and letters flying across the chalkboard, and many of us didn't understand it very well. But now I'd like to open that viewpoint up for you a little bit and think about what I call the 4 big ideas of algebra. Algebra is composed of, first of all, seeking patterns. Anytime a child is seeking patterns, they are thinking algebraically. For example, even at the youngest of ages, in kindergarten, students might look at a color pattern that goes red, blue, red, blue. We might ask them to continue that pattern or predict the 10th element in that pattern. And as they go up through the grades, they study more advanced patterns, such as counting by 5s or looking at a t-table for a linear function. The second component of algebraic thinking is generalizing arithmetic. Students, again, at a fairly young age will realize that an odd number plus an odd number always makes an even number. Conceptually, that's much more advanced than 5 plus 7 equals 12. That would be an example of an arithmetic problem. But once a student realizes that an odd number plus an odd number always makes an even number, now they're generalizing that arithmetic and thinking algebraically. And again, as the students get older, this becomes more advanced. They might think that length times width equals area, or pi r squared equals the area of a circle. The third big idea in algebraic thinking involves symbol manipulation. Algebra has symbols in it, letters and numbers that behave in certain ways. It has symbols like parentheses. And we have rules that govern the way we can manipulate these symbols, these letters, these numbers. Just as our English language has a grammar and a structure to it, so does the algebraic language. Lastly, I want you to think about the multiple ways we can represent algebra to our students. Algebra can be in the form of an equation, but it can also be represented with a graph, a t-table, and the very physical objects that students manipulate as they think about these algebraic situations. So keep these 4 big ideas in mind. Anytime we have students that are exposed to these 4 ways of thinking about algebra, we have their brains thinking algebraically.
Hi, I'm Bill Lombard, and together with Brad Fulton, we are Teacher to Teacher Press. And we'd like to welcome you to our series of algebraic thinking workshops. This is the first of them, and it focuses on a wonderful topic called menu math, where we've used it successfully in all grade levels from grade 4 all the way up to college. And Brad, in just a few moments, is going to be talking about 7 different topics for you. And we're going to start with substitution of variables, writing expressions. Third one is combining like terms. We'll move on to cover properties. Number 5 will be solving equations. 6 is problem solving, and he'll wrap up with a wonderful example of systems of linear equations. And I know you're going to enjoy this. A couple other topics that many teachers have talked to Brad and I about, some concerns and so forth. They watch the 2 of us present at conferences, and they realize that this is a wonderful way to teach mathematics. It really connects with the kids in ways that nothing else does. And one of the topics says, Bill, Brad, we really like this, but how am I going to have the time to add one more thing to my already overloaded curriculum? And the simple response is, take a look at your textbook, and instead of teaching section 3.2, which talks about number and algebraic properties, why don't you just substitute menu math in there, which does the same thing and more? So we're not talking about extra time, and when you look at the results that you get from the kids, especially the engagement, you might find out that you're actually saving time. Frequently when I present workshops, I ask teachers to wear 3 hats. And the first hat is the one that they're very familiar with, the hat of the teacher. As you watch Brad easily present these topics, you'll find yourself saying, I can do that also. The second hat is the hat of a student. You want to be sure that as a student experiencing these activities that you're actively engaged, conceptually and problematically. The third hat is the mathematical hat, and you'll find this hat to be extremely rich. As Brad presents these 7 different approaches to mathematics through the use of menu math, you'll find out that mathematics is indeed solid, rich, and all-encompassing. Most teachers, if they've taught for a while, realize that some lessons don't go over well, and they find themselves spending time reteaching something because it didn't work well the first time. However, when you watch Brad as he presents menu math on a conceptual level, it connects with kids the very first time out of the box, and you find yourself meeting kids' expectations and able to take them from that point into the rich algebra experience. So let's join Brad right now and watch as he presents menu math.
Hi teachers, today I want to show you how to take something very simple, a hamburger menu from a restaurant, and use that to teach 7 key concepts in algebraic thinking. The first concept that I'm going to deal with is substitution of variables, and this is how I present it to students. I show the students this menu, and I ask them to solve the following problems. Here's the first one. Take a moment to solve that. You should have gotten $2.90 for that problem. Let's try another one. Try to solve that problem. On this problem, most students run into some difficulties in figuring out what these letters stand for. The C, they obviously assume means cheeseburger, but the S creates a dilemma. Does it stand for soda or small soda? So they begin to ask me what it stands for. And I act kind of innocent. I say, what do you mean? And they say, well, it could stand for soda, but it could stand for small soda. And I ask them, what do you want it to stand for? And they say, we'd like it to stand for small soda. I said, then it does. At that point, you should have gotten this amount. Let's try one more. Evaluate this expression. On this one, you should have gotten $7.35. Now let's talk about these issues that we've just done. In our first expression, students have substituted values into an expression. This is substitution of variables. In the second expression, though, I made a change. I put in a letter that could lead to some discrepancy. And I like to do that. I think back to when I was in high school, and sometimes the teacher would show us how to solve an equation or to write an expression. And he might say, let X represent the speed of a train leaving Baltimore. And some child would say, where did you get the X? The teacher would say, I made it up. But then the student would say, can we make up things in algebra? And of course they couldn't. But I want students to see that they're in charge of assigning values to these variables and meaning to these variables. I want that to be put into their hands. On this last expression, I wrote a number followed by a letter with no operation sign. There was no addition sign or anything else this time. And again, I can remember this in high school. This is called implied multiplication. And my teacher explained it as, when a coefficient precedes a variable and there's no operator sign between, multiply the value of the coefficient times the value of the variable. And probably that same student said, I don't get it. Why do you multiply? And the teacher would say, well, what would you do? The student might say, I think I'd add. It's a lot easier than multiplying. But when you do this with students, every child is going to multiply 7 times the $1.05 that the fries sell for. It's just natural for them to do that. If you suggest anything else, they say, well, that wouldn't make sense. So what we've looked at here is the first component of algebraic thinking that we're going to derive from this menu, substitution of variables. Now let's look at a second component of algebra. Do your students love word problems as much as mine do? Not at all? Well, let's try to make this a little easier for them. I'm going to give some word problems by speaking in English, some scenarios. I want my students to write those algebraically. For example, I would like 2 cheeseburgers, a medium soda, and an order of fries. That's in English. How do we write that mathematically? I want 2 cheeseburgers and a medium soda and an order of fries. Now, if you want to include review, this would be a good time for your students to evaluate this expression by substituting these numbers as we learned in part 1 of this lesson. You can make these as complex as you want by varying the difficulty of the expression itself. You can make them longer, shorter, adjust them to the level of your class. Now let's move into our third activity using our menu math. What if we have a very long order that we've taken at the front counter? We want to simplify it for the cook. For example, the cook's not going to want to fix a hamburger, then pour a small soda, then cook some fries, put that stuff away, then cook a cheeseburger, then go pour a medium soda, and then start cooking fries again. They're going to want to get all those things done at once to save time. So let's rewrite this order, combining like terms for our cook. For example, how many hamburgers should the cook fix? Well, I have 1 there and 1 there for 2 hamburgers. And I have some small sodas, 1 there and another one here. So I have 2 small sodas. On fries, I have an order of fries there and there and there for a total of 3 orders of fries. Then we have a cheeseburger, and it's all by itself. And lastly, a medium soda. And now I've taken a very large order and condensed it. Let's look at some other things that we can do with combining like terms to help students understand algebra better. Here we have 3 people that have ordered food. The first person ordered a medium soda, cheeseburger, and extra large soda. The second customer ordered the hamburger and the large soda. And the final customer of this group ordered a cheeseburger, fries, and extra large soda. Again, the cook doesn't need to know who ordered what, just how much of each food to cook. So let's combine like terms. How many medium sodas do we have? Only 1. How many cheeseburgers do we have? 2. And I like to have my students underline those so they know that they've accounted for every term in the expression. How many extra large sodas? 2. Then I have a hamburger and a large soda and some fries. Much simpler now. Let's look at some more advanced problems of this idea of combining like terms. Let's say 2 friends walk into the hamburger place. The first customer orders a hamburger and a medium soda. And their friend orders a cheeseburger and fries and a small soda. But then the first customer says, wait a minute, that cheeseburger sounds good. Instead of my hamburger, make it a cheeseburger. I would write that this way. Instead of my hamburger, give me the cheeseburger. Now let's simplify this for the cook by combining like terms. Well, younger learners might see 2 H's and assume there are 2 hamburgers in this order, but they'll quickly notice that this hamburger was removed from the order. It was added here, taken away there. So there are no hamburgers. I've taken care of that part of the order. The number of medium sodas is simply 1. The number of cheeseburgers is now 2. Then we have the fries and the small soda. And that order is now complete. But what if it was written this way? What would this mean? If we saw an expression that had h plus m in parentheses and c plus f plus s in parentheses, and then a subtraction sign, and the h and c were both inside parentheses, what might that mean? Well, this person ordered a hamburger and a medium, and this person ordered a cheeseburger and fries and a small soda, but then they said, we don't want the hamburger and cheeseburger. How do we combine like terms now? Well, we have a hamburger, but later we decided we didn't want it. We have a medium soda, and that stayed. We have a cheeseburger, but they decided we want to remove the hamburger and the cheeseburger, so that's gone also. We still have the fries, and we still have the small soda. This is called distribution of a negative, and it gives many students problems in algebra. But with this concept where they can see I am removing everything in that parentheses, they see that not only is a hamburger negative, but the cheeseburger is negative also. Another concept we can teach very easily using this menu are the mathematical properties that show up so often in algebra and confuse our students. We want them to be fluent with these properties, so let's look at ways to easily show them how these properties work. Let's start with the commutative property, one of the easiest. That would say that h plus m is equal to m plus h. Every student's going to realize that's true. It simply says, if you go up and order a hamburger and a medium soda, don't complain if you get a medium soda and a hamburger. It's the same order. Here's a second property we can illustrate very easily with this menu, the associative property. Let's say one person orders fries and a small soda, and their friend orders a large soda. That will cost the same amount of money as if the first person ordered fries and the second person ordered the small and the large sodas. There's no difference in price simply because we order it differently. That's the associative property. Here's one of my favorite properties to teach using this menu. And I'm not going to tell you which property I'm demonstrating because I want you to discover it as we go along. But let's set up a scenario. Let's say I'm the cook at this hamburger restaurant, and one day I see an order that's given to me, and it says this. Now, what should I cook for these people? Well, quite obviously, I want to cook 3 hamburgers and 3 fries. Later, I see a second order come up, and it says, what do I cook for this? Clearly, it's 3 hamburgers and 1 order of fries. Yet later I see a third order that kind of looks like these two, but kind of different. Let's see what I would cook if I got this order. My students immediately tell me they would cook 3 hamburgers and 3 fries. I act surprised. I say, are you sure? They say, well, of course. I say, well, this order actually looks a lot more like that order. I have 3 in front of an H, and I have a fry with no number next to it. They say, no, that's going to be 3 orders of hamburgers and 3 orders of fries. And then I say, so you're telling me that this order is equal to this order? And they say, well, of course it is, Mr. Fulton. Clearly, they have come to understand how the distributive property works. Once my students have seen that, it is very easy to transition them from simple problems involving the distributive property to much more complicated ones. I've successfully had 4th graders start with this and move on to more complex problems like this one, and this one, and so on. Once we get students to see this type of distribution, we can then take them to more abstract levels, such as, what if I were to put in letters they've never seen before? And very soon, students are using distributive property exactly as it appears in an algebra book. Now let's take a look at a property that gives a lot of students difficulty. That's the transitive property. These menu prices were set up specifically to develop this. You'll notice that a hamburger and cheeseburger sell for $4. But because of the other prices, you can order 2 orders of fries and 2 small sodas for the same price as a hamburger and cheeseburger. Therefore, we can conclude that the 2 fries and the 2 small sodas must also sell for $4. Typically, in an algebra book, this is written as, if A equals B and B equals C, then A is equal to C. That's the transitive property. Now let's talk about the heart and soul of algebra, being able to solve an equation. It's very easy to do with a menu. Simply write an expression in which one of the letters is wrong. It's not representative of anything that we see in the menu. And give the total price of the order. Students then have to figure out what is that mystery item. Here's an example. C plus B costs $4.20. What does that B stand for? Well, students know that the letter C must correspond to the cheeseburger, so that's $2.15. They simply subtract the cheeseburger from the total price. And find out that B costs $2.05. Therefore, it must be the extra large soda. Now, interestingly enough, young children will actually solve these this way. They may not write it algebraically as I have done, using things such as the additive inverse and balancing both sides of the equation. But even young children, rather than guess and check their way through this chart, will realize I need to take the C, which has a known value, and subtract it from the total to find what's remaining. I've done this with students as young as 4th grade, and they go through it with no instructions whatsoever. They figure this out on their own. Now let's look at a more challenging equation. 2F plus D costs $3.05. What could that D stand for? Students know that the F's are fries. So that's 2 orders of fries. 2 orders of fries plus the D costs $3.05. 2 orders of fries would cost $2.10. Now it looks like the equation that we solved a moment ago. I'll remove the known amount from the total amount, and I will find out that D costs 95 cents. So D must stand for a small soda. You can make these equations as complex as you want. You can incorporate parentheses, using the distributive property, combining of like terms, variables on both sides of the equation. Make sure you design them to suit the needs of your students. Now let's look at another avenue we can explore with our menu. This is called problem solving. We have an order here that's been written up, but as you can see, someone spilled ketchup on the order. I'm not even sure what we ought to be cooking or how much it cost. But let's take a closer look at this. We know that the total order cost $5.20. We know it included a hamburger for $1.85 and 2 orders of fries for $2 and something, and one other mystery item. Can we use algebra to help us figure out what we're supposed to cook? Well, first of all, we can take what we know and write it into an equation. I have 1h plus 2f plus 1, I'll call it a n, equals $5.20. But I know that that one hamburger is $1.85. I also know that 2 orders of fries can be calculated from our menu. They would cost $2.10. Now I have an equation in one variable, and I can solve that. I combine like terms to get $3.95 plus my n costs $5.20. Removing the $3.95 that I know from the order leaves me that n sells for $1.25. That must mean that it's a medium soda. And again, we can make these as complicated for our students or as simple as our class dictates. So far, we covered 6 different concepts that you can teach with algebra using this menu. And these have been used in our middle school classrooms, but I've also used them with students as young as 4th grade. And they've also been used at our local community college to introduce adults to algebraic concepts. Now, there's only one thing we change when we take this down to students who are younger, like in the 4th grade. We teach the exact same algebraic concepts, but we simply change the prices to arithmetic with which they're more comfortable. Simply changing these prices will allow the students to perform these same calculations and understand the exact same concepts that we do with much older students in a formal algebra class. Let's say that we're now at a restaurant that has different prices than the one that we've been at previously in the other 6 activities. And unfortunately, I forgot my glasses. I can't even read the menu to tell you what the prices are. However, I can hear the customers in front of me as they order food. A few people up in line ordered this food, 3 hamburgers and 2 orders of fries, and they were charged $13. Now there could be a lot of different values that we could have for the hamburger and fries. That might be a $4 hamburger, making this portion of this equation worth $12. Then 2 orders of 50-cent fries would make the other dollar for $13. But there are many other solutions too. As the price of the hamburger drops, the fries value would go up, and vice versa. So I can't really tell you what a hamburger is worth or a fry is worth at this restaurant. But then another customer ordered this food, a hamburger and 2 orders of fries, and they were charged $7. Now when I've done this in my classroom, you can see the light come on in these students. You can hear the ahas. And I asked the students what they've discovered, and they said that there's some similarities and some differences in these orders. Well, let's take a look at the differences of these orders. We're going to take one order and subtract the other order from it. What's different about the price? $6. But what's different about the food? Well, there's no difference in the number of fries. 2 orders of fries minus 2 orders of fries leaves nothing. That's eliminated. But 3 hamburgers minus 1 hamburgers shows us that we have a difference of 2 hamburgers. And most of us would agree now that once we've gotten this far, this equation is essentially solved. If 2 hamburgers sell for $6, then 1 hamburger would sell for $3. And once we know the value of a hamburger, we can take one of these equations, such as a hamburger plus 2 orders of fries cost $7, and we can solve that equation to find the value of the fries. By removing 3 from both sides of the equation, we get 2 orders of fries cost $4, and dividing by our coefficient gives us that the fries cost $2. Systems of equations introduced with a simple hamburger menu.
Brad and I want to thank you for joining us in our Simply Great Math Activities video series. We're sure your students will enjoy and benefit from menu math as much as ours have. You'll see their understanding and their excitement grow as you implement these engaging lessons. Students with no previous experience and also students who have struggled in algebra in the past will see their math skills soar. On another note, look for more activities in our series on our website at tttpress.com. You'll also be able to download many other activities and newsletters at no cost, browse our bookstore, connect to other resources, or even schedule a workshop in your area. And here's wishing you happy teaching.
Say that